So yesterday we started talking about measures of central tendency, and specifically those were mean, median, and mode. We also talked about, in order to have good data, we need to have both. We have to look at both our measures of central tendency as well as variation, or our data spread. We looked at one way to calculate our spread of data or our variation, and that was by our range. So that wasn't necessarily the best, and it says a disadvantage of using the range to describe the spread of data is data set is that it uses only two data values. A measure of variation that uses all the values of data is the standard deviation. So what is the standard deviation? It says that the standard deviation of a numerical data set is a measure of how much a typical value in the data set differs from the mean. Okay? It's very, very important in the sense that it tells us how good our mean is at estimating our average, right? Remember, it can be very far off depending on if the data is skewed, for example. And I have in your packet two articles that I want you to read. One talks about the general use of standard deviation, and the other talks about standard deviation with regard to, hold on, do you have something to say? You have something to say? Then stop talking. Okay. The other one talks about standard deviation with regard to athletes and performance. So we're going to take a look at that. Now, again, it looks a bit confusing. It says that the symbol sigma represents the standard deviation. It is read as sigma. It is given by the following. Where n is the number of values in the data set, the deviation of a data value x is the difference of the data value and the mean of the data set. So we have very specific steps we need to follow. First, we're going to find the mean of our data. We know how to do that. We add all the numbers together and divide by the total number in our set, right? So step one is pretty standard, pretty simple. The next step, well, now we're going to find the difference between the mean and each value in our data set, okay? And we'll put this to use with one example here in a moment. So this is just the difference between that mean that you found and every numerical value in your data set. That's going to be another part of your table that we're going to put together. Does that make sense? Once you do that, you're going to take those resulting values when you find the difference between the mean and each numerical value in the data set, and you're going to square them. Okay? So far it's really not that bad. You're just finding the mean. Sammy. You're just finding the mean, finding the difference, squaring that difference, and then you're finding the mean again. There's a specific word for that. When you find the mean of this value in step 3, you're finding the variance, okay? And then to find, lastly, the standard deviation, you square root that. So it's a lot of steps. They're each simple steps, but sort of putting it all together in one big picture can be a little bit confusing. So what does this all mean? Well, it says down here, a small standard deviation means that the data are clustered around the mean, so that's good. A large standard deviation means that the data are more spread out. Again, when we're trying to think about what is a good measure of our data, trying to decide whether it's the median or the mean, if we have a small standard deviation, then that would indicate that the mean is a good numerical value to use to analyze our data. So, does anybody have any questions so far? Anyone still writing? Okay. So in order to calculate the standard deviation by hand, I'm literally just going to give you one problem to do to add to your homework because it is very time consuming. The first thing that you want to do is list all your data. Yeah? Find the mean of all this data. It should all be the same, right? If you add all these numbers and divide by the total number in this set, you should get 25, right? So you just extend it downwards. The mean's going to be the same, right? Because it's the mean for the entire set. Does that make sense? Okay. Once you do that, you want to find the difference between the mean and each value in the data set. 25 minus 20, or 20 and 25, 29 and 25, 19 and 25, 22 and 25. You take that value and subtract it from the mean. Does that make sense? Then you get all these numbers. So again, it's really not that bad. It's just a lot of work, right? And then you take all those values and you square them. So you get 25, 16, 36, 9, 0, 4, 4, 16, 25, 25, 16, 36. Does that make sense so far? And that's what they talk about here. They say find the mean, find the deviation. This is called the deviation of each value. Square each deviation. And then you want to find the mean of the squared deviations or variance. So you're going to take all these, add them all together, divide by the total, right? And then that's how they got this. They found the mean again. It's the mean of the mean, essentially. And they're still not done, okay? This is called the variance. It's not the standard deviation. Then you square root it, and you finally get your answer. So it is just a systematic process, meaning step by step. If you follow the steps, you won't get it wrong. It's just a lot of steps, okay? And you can't be fearful of the steps. The process, if it were difficult, maybe, but it's, you know, within the scope of your abilities. You know how to find the mean. You know how to find the difference between the mean and each value in your data set. You know how to square that, right? And then you can just add all of these together, find the mean again, square root it, and you have your answer, okay? So again, I'm not going to have you do very many of these by hand, just one. But, lucky for us, technology has helped ease this process, and I'm going to show you how to make this very simple using an Excel spreadsheet. So, here we go. Do you have any questions so far? Yes? What is the 4.2? Oh, yes. So, the 4.2 is your standard deviation, which means that, so your standard deviation is how close your data is to the mean, right? So it's going to make more sense as in the articles that I gave you. It's going to talk about why standard deviation is useful, okay? So before we get to that, though, I want to show you how to calculate it with an Excel spreadsheet. Okay, so I'm going to open up my Excel spreadsheet, and they want me to use the ages for show B in example 3. So this is what I'm going to do. And I have this for you on my teacher website if you want to do the extra credit. All I did was I input the values in one column, and I labeled it X, right? These are all the values for the contestants. Does that make sense? Okay. So now I have to find the mean of all those values. So this is what I'm going to do. I'm going to write equals, and I'm going to put parentheses, or no, I'm going to write equals average. Okay. Let's see here. Why is it not? Oh, I know what it's doing. Okay. There we go. Equals. I need it to show up on this because this is a formula that I'm inputting. Equals average. And then I want the mean from A2 to A13, right? So I'm going to type in A2 to A13. Oops. A2 to A13. I'm going to close my parentheses. Now, what's going to end up happening if I do just this is it's going to not give me a single mean. I want the same value, right? Because my mean's not going to change. So in order to freeze that value, what I'm going to do is I'm going to put these little dollar signs here. Dollar sign, dollar sign, dollar sign, dollar sign. And that's what's finding the absolute mean. I press enter, and I have 26. It found my mean for me. Right? So now I just want to copy that all the way down, so I just simply drag all the way down. Why it shows the X bar for all of it, I don't know. But it just calculated my means. Does that make sense? Okay? And then I have those instructions for you here, step by step, if you want to follow along when you do it by yourself. Okay? So now, I have to find the difference between this X value and this mean, correct? So here's what I'm going to do. You always start with equals, and you tell it what you want to do. Okay, I'm going to say equals, and I want to find the difference. I want to find the difference between A2 and what else? Yeah, B2. A2 minus B2. And then I'm going to press enter. Well, 25 minus 26 is -1, right? I don't want that value to be the same all the way through. I'm not going to add the dollar signs. I want it to apply the difference for all of these, right? So I'm just going to drag and drop. 48 minus 26 is 22, right? So you get all of these values here. 24 minus 26 is -2. Does that make sense? So it found the differences for you, so you didn't have to do it by hand. Well, now what do I have to do? I have to take that value and I have to square it. So, turn to the next page. Step number 6. I want to take this value and I want to square it. Squaring means I'm going to multiply something by itself, correct? So I'm going to take C2 and multiply it by C2, right? So equals C2 times, and you have to use a little asterisk here, C2. And press enter. Well, that makes sense. -1 squared is 1, right? And then I wanted to apply that throughout all of them. So now I'm just going to drag and drop. Does that make sense? Again, it's a little annoying. I don't know why they would put the minus squared for the deviation there for all of it, but once I figure out how to fix that, I will tell you. Okay, well, if we go back to what we looked at before in that previous example, what did it tell us? It said that once we do all of that, what do we have to do now? I'm going to go back here. It says find the mean of the squared deviations or the variance. I have to find the mean, right? I have to find that average again. So I'm going to go back and I want that average. So I'm going to say equals average. I want the average. And what do I want the average of? D2 to what? Yeah, D2 to D13. So D2 colon D13. So that colon means 2. D2 to D13. See how it highlighted all of that? It's going to take the average of all of these. You press enter, and there you go. You have that variance. You have that average of all those values. Does that make sense? Well, the last thing to do for my standard deviation is just to square root that. We talked before how when you square root something, it's the same thing as taking it to what power? Remember? Half, right. So, I'm just going to take that previous value, and that would be D15. So, equals D15. And I'm going to raise it, so I use that little caret symbol, to 0.5. And there is my standard deviation. Does that make sense? Okay. Again, if you need to see it again, you can watch this video. I have a small data set that I want you to do, well, that you can do for extra credit on an Excel spreadsheet. Print it out. Use the formatting that I gave you, right? And of course, I'm assuming that, again, you're doing this on your own, you know, because there is value in doing this on your own, of course. So, anybody have any questions about using an Excel spreadsheet to find the standard deviation? Okay. So, what is a data transformation? Basically, if you want to increase your data by 10%, the measures of center increase by 10%. right? So whatever you get for your mean, median, and mode, increase that by 10%. Does that make sense? If you want to increase everything by 2, then whatever your mean, median, and mode is, increase it by that same amount. It says when a real number k is added to each value in a numerical data set, the measures of center of the new data set can be found by adding k to the original measures of center. You just add it to your mean, median, and mode. Now this is important. The measures of variation of the new data set are the same as the original measures of variation. They say that the standard deviation stays the same because the amount by which each data value deviates from the mean stays the same. So if you're increasing your data by 10%, your variation, your measures of variation, your standard deviation is going to stay the same. Okay? It's only your measures of center that are affected. If you're multiplying, the same thing holds true. When each value in a numerical data set is multiplied by a real number, or k is greater than 0, the measures of center and variation can be found by multiplying the original measures of k. So whatever you get for your mean, median, and mode, and you want to change it by a certain amount and multiply it, then multiply the mean, median, and mode. You don't have to go back and change all your data. Does that make sense? Okay. And that's all that says. And this is it pretty much that I have for the lesson. Do you have any questions? Okay. Keep in mind, if you want to do the extra credit, which I have on the next slide, I have the Excel formatting on my teacher web. Again, I'm trusting that you're doing this on your own. You're not going to copy it and spread it around like wildfire, you know? Because, again, there's value in actually doing this yourself. It's not going to be very many extracurriculars, but, you know, I do like to see that some of you try. So what do I want you to do with those articles? Well, I want you to do one of them by hand. It's a very small data set. Okay, very small. So number 20 by hand. And that's in your book on page 590. And I did make that a separate assignment because I want that on a separate page than number 1. And then I want you to answer the prompts. You have 2 small little articles to read. One's half a page, one's a page. One of them, this first article, will answer the first prompt. Why is standard deviation an important statistic? I want you to answer that question. It just has to be 1, maybe 2 sentences at the most. And then number 2, what can standard deviation say about an athlete's consistency? So for those of you who play sports, it is a very important statistic in determining an athlete's consistency. So, does anybody have any questions? Okay, you know what to do. You can start with whatever you want. You can answer the prompts first, and then do number 20 by hand, or you can do number 20 by hand first while I'm here to help you out, and then do the prompts.